Okay, good morning, good afternoon, everyone. I'm Juliette Laurent. I work at the CCAC Secretariat. Very happy to welcome you today to this webinar where we'll be discussing utilization of satellite data and air pollution forecasting to support policies banning agricultural burning. So today's webinar will be focusing on the Greater Mekong Subregion, and we'll hear from experts from the Thai Pollution Control Department, the Lao Natural Resources and Environment Research Institute, the Asian Disaster Preparedness Center, and the German Development Agency, GIZ. So if you have any questions for our speakers, you can write them down in the chat. We'll have 2 Q&A sessions throughout the webinar. So now I would like to give the floor to our first speaker, Dr. Sagda Tridesh, who is a specialist in air quality modeling from the Thai Pollution Control Department. So he will tell us about the work that the PCD has been doing to combat fire hotspots using satellite data and air pollution forecast. Dr. Sagda, the floor is yours.
Okay, thank you very much, Juliet. First of all, can you hear me clearly?
Yes,
okay.
We can hear you.
Okay, thank you. First of all, I would like to share my presentation. I think, okay, just a minute, please. Okay. Okay, right. Can you hear my? Can you see my presentation?
Yes.
Okay. Okay. First of all, I would like to say, I shall say, good afternoon for European time and good evening for the Greater Mekong Subregion. Today, my topic is satellite data and air pollution forecast to support policy banning agriculture burning. Actually, this is just like to sharing my experience. Okay. Okay, first of all, the starting point is start from the National Action Plan of Thailand to mitigate the PM2.5 problem. This National Action Plan is start from around 5 or 6 years ago. In that plan, it said that in Thailand, we must have the forecasting system. And the forecasting system, we hope that it can be forecast in advance 3 and 5 days to inform our people. Then our people can prepare themselves to stay safe, because the major objective is to protect our people health. In our forecasting system, it consists of actually 3 parts. The first part is the observation data. Nowadays in Thailand, we have around almost 96 air quality monitoring stations for the whole domain of Thailand. And we also have a mobile unit for 9 units. This observation data we use in both ways. The first way we use for the observation and to inform the real-time situation for our people. But in forecasting system, we use this kind of data for validation. In each monitoring station, we have normally 6 parameters: PM10, PM2.5, CO, nitrogen dioxide, sulfur dioxide, and ozone. Because in Thailand, our air quality index, we calculated from these 6 parameters. Our forecasting system, we developed actually around 8 or 9 years ago. at the starting point, we use just the basic dispersion model. But when we need to attack the PM2.5 problem, we skip from just a normal dispersion model to chemical transport model. Nowadays, in our forecasting system, we use the mathematical model called WRFChem, Weather Research Forecast Model. However, I think in this webinar, I think maybe most of you guys knows how to use a mathematical model, or maybe you might be heard before. At the first step in our country, when we try to use a mathematical model to make a PM2.5 forecast, we use the input data, just emission inventory. However, we know that if we use just only emission inventory, it just static data. It's not the dynamic. So then, when we know that this kind of problem last 4 or 5 years ago, we try to use more dynamic data, is the fire hotspot data from the satellite, because the emission inventory data, we cannot make it the near real time, or we cannot make it more high temporal resolution. But for fire hotspot data, nowadays we can have more temporal resolution for the hotspot data. Last 5 or 6 years ago, we use satellite data from MODIS, but nowadays we use the satellite data for the hotspot data from WIRS, because the major thing is the resolution of the data. I think you guys know that for the MODIS data, the resolution is in the unit of kilometers, but for WIRS is meters. So the resolution of WIRS is 375 meter. So this kind of resolution make more accuracy. And then we also use meteorological data from GFS, Global Forecast System, and also ECMWF. When we try to use both of data and use the input data, the source, emission source, that more dynamic, so it returns more accuracy. However, last 4 years ago, when we try to make the forecasting system more efficiency, we suffer some problem. When we try to use a chemical transport model, we could not use the typical workstation. But fortunately, in Thailand, we have a high performance computing unit. Last 5 or 4 years ago, we use the workstation that has just around almost 4,000 cores processing. But nowadays, we have in our country, in Thailand, we have a new HPC, high performance computing unit, that has around 32,000 core processing. So it make it faster and more efficiency. So nowadays, we can make the simulation forecast for in advance around 7 to 10 days in advance. But in the near future, we try to make the more resolution, and we try to make the simulation forecast for around 16 days in advance. And this is how the simulation results looks like. This simulation result, I did it in early of this year when Thailand we encountered the PM2.5 episode. So this domain we can make it for the whole domain for our greater macro subregion. When we put emission inventory combined with hotspot data, so we can see where's the direction of a PM2.5 plume, where it's going to be in terms of the direction. And the color shading, we use our National Air Quality Index. So we can make like a preventive planning. We know in advance for 7 days. So in terms of both budget planning and also human resource planning is more effective because we know the direction, we know where it's going to be. Oh, sorry. If you see in this result is a good response because in this early of this year the hotspot location, most of the hotspot location occur in the east part of our country. So we know where is the impact that's going to affect which part of our country. And for about the use case, of how to use the forecasting system, first is for data dissemination. When we know the real-time situation for the monitoring network and also for the forecasting result, we can disseminate this kind of result via our application called Air Forti. So our people can know that what exactly for the current situation, and they can know the situation for in advance for 7 days. So they can prepare themselves, especially for the youth age and for the elder age. Well, when we need to do work from home. And for more use case, this use case is this early of this year, around February. On that time, in Bangkok metropolitan, the concentration of PM2.5 is so much higher. So the Prime Minister he came to the pollution control department, and I present him what we forecast and what the situation is going to be, and he used my result, and then he announced for work from home because I told him that the situation is getting worse for 2 days. And then the Prime Minister, he contact with the mayor of Bangkok, Dr. Chacha. And then mayor of Bangkok, he announced for work from home for 2 days. So this is a use case that we use the hotspot data combining with our forecasting system to warn our people. And the last part of our forecasting system, we have the application called burn check application. What is the burn check application? If I would like to give some definition of the burn check, is like the fire reservation for agriculture. Because in Thailand, when we try to announce to stop farmer to stop for burning, it's not work. Because when our government try to announce to stop the burning, it's written like a resistance. So we have an idea that so we need some kind like the fire reservation, because in pollution control department we can make a forecasting. We can know that where is the situation going to be. So in this system, we our farmer, they can make like a reservation, and the system will return the result that agree or not agree. Because if the forecasting system say that it's going to be like an inversion in next 3 days, the system will tell our farmer that, okay, try another day. Don't do the burning for this next 3 days. So this is a bird check application. We use this system, I think, around 2 or 3 years ago. But in the near future, we think that this kind of the application may be more efficiently for our country. So this is this is all of my presentation. So thank you very much for your attention. Thank you.
Thank you so much, Dr. Sagdar. It's very impressive to see how, like, all the innovative solutions that are being implemented in Thailand, and also the focus on disseminating information, which of course is key in raising awareness. Thank you, and to our audience, again, if you have questions for Dr. Sagdar, please write them down in the chat, and we'll go over them in a few minutes. Now I'd like to turn to our second speaker, Ms. Bunmani Solidet, who is acting head of division at the Natural Resources and Environment Research Institute of Leo PDR. Bunmani will tell us how the institute is integrating satellite data and air pollution models outputs to detect agricultural burning and enforce ban policies. So Bunmani, the floor is yours. Bunmani, I think you are on mute. Can you open your mic?
Yes, may I share the screen?
Yes, please.
Do you see my screen?
We see your screen, but not your presentation at the moment. Would you like me to share your presentation?
Oh, okay. Got it. You see my screen? All right.
Yeah, we can see your presentation.
Okay. Okay. Good evening, everyone. I'm Bunmani from Natural Resources and Environment Research Institute, National Focal Point for Transboundary Haze Pollution, Lao PDR. Today, I would like to share you some information on the satellite data and the air pollution forecast to support the policy burning agriculture burning in our country. Come to the introduction. The agriculture burning is very significant main contributor to contribute the air pollutant in Laos, particularly during the dry season on March and April in every years. We are facing the haze pollution in 2019 and 2023, and this year for the transboundary haze pollution. So the information on the burn area and associated with the air pollution level is very critical and implementing effective policy to ban agriculture burning. The satellite data and the air pollution forecasting model very important and can provide us a very significant support to our decision maker. For the prevention of the forest fire or agriculture burning, we have hotspot observation from the satellite data and information from the ASEAN Specialist Methodology Center from Singapore. So you can see that the statistic count for the hotspot from 10 years, we can see that 2020-23 is very high count most compared to the 10 years ago. Because maybe the satellite sensor or the new technology come, and then so the hotspot count is very high. So the next, we use the second information from the ASMC website or through the ASEAN Secretariat. So we can get from the second information about 5 p.m. In the evening. So it's quite late. It's not a real-time observation for us. So after that, we get the hotspot information and the coordinate of the hotspot, very high confidence, then we can put into our mapping and forecasting. And forecasting is used the regional models to forecast on the transboundary haze pollution and haze situation together with the air quality monitoring station. So far, we have 8 stations for the reference station. Only the dust station or PM2.5 station in the north part and in the southern part of the Lao PDR. And we also have the non-reference station, about 20 devices. So we are now currently has the division called the GIS information and mapping. We are now using also the satellite data for the burning area detection. Mostly we also use the satellite, the sensor from the MODIS and the VIR, and the Landsat for the estimate or look back the burnt area detection. The air pollution forecast model, so far our division has limited capacity regarding to the human resources and also the technology and the high performance of the computer. So the forecast in the for model in the future, we also want to use like Thailand, the WRF camp that can forecast in advance. So at least 3 days in advance to announce the to the public during the dry season. But so far, due to the limit of the capacity, so we cannot predict or forecasting in nowadays. The integrating satellite data and air pollution forecasting, we want to integrate the satellite information to see the burnt area, to identify the source or the source of the pollution, because mainly the agriculture residual burning is from the agriculture area, and also together to look at the emission estimation. And also for the model input, the incorporate and estimate emission into the air pollution model to simulate the impact of the agricultural burning on the air quality. Yes, of course, and also as I mentioned, forecasting is used the model to predict the 4-day this is still a limitation for us on this. Well, with the satellite information and air quality monitoring station. It's very critical information and data to support to the policy maker to decide it to do something or management on the air quality in Laos, especially on the awareness dressings, and the enforcement will be later on after the awareness, after the public understand about the air pollution. So the policy will be support on the enforcement later, because so far we don't want to enforce to the villager, because the main burn the agriculture is from the villager. It's not the big company yet. So that regarding to the policy. However, this so far the policy on the agriculture burning still not existing in the any policy in the agriculture and environment yet. So last but not least, I would like to say on the challenges and opportunity for us. So the first one is the talking about data, to ensure the quality of data is accurate of from the, especially from the satellite data and data information and the emission, because we have a limitation of the ground reference station. So satellite data and information is very important for the area that not has the reference station, and also the satellite information is very important for us to do the prevention, especially see the observation of the hotspot and also the burn area. And the accuracy of the model, especially for the validation and the data input to the bottom, it's very challenging for us. And also the resource of data, and also the institutional capacity building for the government agency and government officer on the satellite and air pollution model is very insufficient so far. So I would like to end my presentation here. Thank you very much for your attention. Thank you.
Many thanks, Bunmani, for your presentation. We will now move to questions from the audience. We have a few questions in the chat. Maybe first a question for you, Bunmani. You've mentioned raising public awareness on the health and environmental impacts of agricultural burning, and you've also mentioned that the first players engaging in agricultural burning are small farmholders and not necessarily the biggest companies. So could you tell us a bit more about what kind of awareness raising activities are being implemented in Laos to the farmer community?
The first one is on the awareness raising that we are doing for the agriculture burning is very less, especially related to the open burning. It's very limited on the information. So far, the agriculture agency and forest agency, they still saying that air pollution is not come from the agriculture sector. So that's why we need to raise awareness to the farmer and to the agency, to the local government, as well, that to mention that the air pollution is come from the agriculture sector. We need accuracy data and information to indicate that pollution is come from the agriculture sector, because they aware that the air pollution is come from industry and also come from more on the transportation. In comparison to the agriculture, is very short periods, like 1 month, 2 months that they are facing. But we concerned that the short periods about 1 or 2 months that the air quality is very higher than the WHO standard. It's very important more than the 1 year's whole year that we are facing the pollution. Not only the dust, but also the gas as well. That the whole year that we are facing. But in that period, raining season, it's quite windy and it's raining. So it can reduce the PM 2.5 concentration. So I can say that the awareness raising in the public, to the communities, to the local government, still limitation for us, very challenge for us to change their practices, because the farmer, they still understand that if they are not burned, the agriculture product is less. They still understand that. So there is no scientific proof on the burn and or unburned area from the agriculture product. So yeah, because if we want to do enforcement, mostly is the farmer, mostly is the poor people, they are doing agriculture farming. It's related to the livelihood. It is different from Europe, you know, in our country. 80% of the income is come from agriculture. So yes, the company is, it has some, because the cassava plantation and the sugar cane plantation is now quite wide of the business. But however, if the business, we can enforce them easily. But for the farmer and for the land on the highland, they can say that the highland plantation is very hard to control. So we need some technology, or we need some scientific to prove on the agriculture product. I can say that we have very limited information and research on the burn and unburn area on the agriculture product. Yes, I can say that.
Thank you. Moving on to the next question. Someone is wondering what is the type of agriculture residue that is being burned, and are there any current policies which have made a difference in minimizing the burning? I think this question can be addressed both by Bunmani and by Dr. Sagda.
Yeah, maybe I can go first for the agriculture residual burn in our country. First of all is the straw, the paddy rice after the harvest. It still has some residual remain in the area, so they burn. In English, they call the straw. I'm not sure in English. Maybe Dr. Sakda can help me. Phương in Lao, and maybe Mr. AJ also can help me. Yeah, it is the store. So mainly is that one, and some is the cassava as well. Cassava and the sugar cane has been burned during the dry season, and there are some any policy currents have been made different to minimize. I think no, we have very limited in terms of the policy, because we have interviewed the agriculture agency. They said that the organic farm certificate, or the organic criteria, or the standard that company to receive the organic certificate, it's included in that standard. But in practice, I see none in terms of the policy to control the burn of the residual burn. So this one we need to review on the policy as well.
Thank you, Bunmani. Dr. Sagda, do you want to jump in on this question as well?
Okay, sorry, I forgot to turn on my microphone. Actually, for this question, agricultural residual burn, I think it's in my country is same as Bunmani said. Also in Thailand, agriculture residual burn is come from after harvesting rice, sugarcane, and also corn. Yeah, from after harvesting these three types, rice, sugarcane, and corn. This is major things in my country.
Okay, thank you, Dr. Sagda. I think we had another question directed to you regarding the Burn Check app. Could you tell us a bit more, and in particular, who developed the app and who has access to it? And who do you think is mostly using the app that you've mentioned?
Okay, thank you very much for the question. The first thing that who is the developer? Actually, the developer is the GISDA Thailand. Is the organization that in charge directly in charge for the satellite product. GISDA they cooperate with the Pollution Control Department Thailand. We work together to develop this application. And this application it is just for agriculture area, not for forest area. And the mechanism in this application is like I did mention in my presentation, is for farmer. When the farmer they would like to make the open burning after harvesting, uh, they can make like a request for to make the open burning. And in the mechanism of this application, it used my forecasting result. And when let me say for example, if the farmer they would like to make open burning, let's say tomorrow, and the application will see my simulation result. If the simulation result said tomorrow, it seemed to be like gonna happen inversion, and the situation gonna be exceed our national standard. The result will return to the farmer that reject or refuse. But if the forecasting result is says tomorrow the ventilation rate is 5, so it's going to be returned. Okay, you can make the open burning. So the main objective of the burn check application is for farmer, for agriculture area, not for forest fire. So I think if you have a further question, maybe you can email to my email and I can answer. Thank you.
Sorry. Thank you, Dr. Sagda. Another question from the chat that I will be reading out. So, agricultural burning is time-based on a cropping cycle. So are there any modeling approaches making predictive assessments in advance of the burning with the purpose of deploying temporal-spatially targeted extension messaging, either as a standalone to encourage alternatives to burning or to integrate it into permitting and other approaches? Either Bunmani or Dr. Sagda, if you want to take this question.
Excuse me, Pulmani, do you want to go first or?
No, Dr. Sakla, you can go ahead. I never used this information before. Yeah, please.
Okay. Actually, maybe I could not answer more clearly because the model that I use is atmospheric, based on atmospheric size. But for the cycle of how can I say, for the crop cycle, in Thailand, I think I heard that some researcher in Thailand they try try to forecast this kind of a cycle, but I don't have much information. But I think in my country, some group of researchers they try to make a deep investigation for this kind of model. So, but if I have more information, I think I can share with you guys. Thank you.
Thank you. Budmani, did you want to address this question as well? If not, we have one final question from the chat, asking you if you have experience in using the Integrated Global Greenhouse Gas Information System, or IG3IS, which is an observation-based information system for determining trends and distribution of greenhouse gases in the atmosphere.
No, I don't have any experience on this because the GHG is in the Department of the Climate Change. They are using these models. Yeah.
If, for me, it's same as the Bunmani because in Thailand, we make separately for air pollution and greenhouse gas. We have a different department that directly in charge for greenhouse gas. So in that department, they also use this kind of a model. But for me, I use just atmospheric side base for air pollution, like PM 2.5, aerosol base or gas base, something like that. But I never used for greenhouse gas before. Thank you.
Okay, that's clear. Thank you so much, Bunmani and Dr. Sagda, for your presentations. We'll now move to the second part of the webinar, where we'll hear about regional initiatives to address agricultural burning using satellite data and air pollution forecasting. And first, I would like to give the floor to Akepol AJ, who is Geospatial Manager for Air Quality and Health at the Asian Disaster Preparedness Center, and who will present the survey program and how they are leveraging air quality data for smarter agricultural burning and fuel management decisions. AJ, the floor is yours. Thank you.
Thank you, Juliet. Hello, everyone. Juliet, can you confirm you hear me and you see my presentation full screen, please?
I can hear you, but I do not see your presentation.
Oh, okay. Okay.
Yeah.
Here we go, full screen.
Perfect.
All right, thank you. Hello again. My name is AJ, a Geospatial Manager on the Air Quality and Health under the Asian Disaster Preparedness Center. I'm going to talk about how we use the satellite data to manage the agricultural burning. And then we have under the ADPC, Asian Disaster Preparedness Center, we have one project called Surveyor Southeast Asia. It aims to promote the use of freely available satellite data and technology to manage to address the problems relating to climate change, flood, drought, and one of the hot issue in this region is the air quality. And then we are not only working for Southeast Asia region, we have a hub in the South America, the Africa, and then in the Hindu Kush, Himalaya, and then here we are, the Southeast Asia. We are trying to bridge the gap. We are trying to bring the science and data and technology to the end users. So the question here is that how we can use the satellite data and air pollution forecast to support the policies banning agricultural burning. Let's see now, here we go. Let's look at the problem first. This is 18 years average of on the left, the fire hotspots. You can see there are frequent fires on the northern of Laos, somewhere in the north of Thailand and Myanmar. And looking at the trend, It goes up in Laos, in Thailand as well, and Myanmar, and some part in Cambodia, and that will contribute to the, of course, the particulate matter, especially the PM2.5. You can see the trend says the same. And from this problem, it has a lot of impacts on the, for example, the 80 million people impacted by the smoke, 50 million hectare is prone to the fire, and not to mention about the more than 100 people suffers from the premature death. This is 2015. The number has gone up actually, and then from these problems, the starting from Thailand and Laos, the authority have installed the air monitoring stations, as you see in Thailand, as Dr. Sakda mentioned, 96 stations for now, and around 10 in Laos. And then the question is, if we want to monitor the air quality, how about those areas that we do not have these stations? Then our project promoting the satellite technology, we try to use the, we call it the global air simulation model. It's called GEOS5 to provide the real-time and also the 3-day forecast of the air pollution data. Of course, as you know, the satellite data, they are never accurate, right? So the thing is that we need to use the ground data from the Pollution Control Department of Thailand and from the Monray Ministry of Natural Resources and Environment from Laos to calibrate this data. So here we go. We use the machine learning algorithm, the random forest, as everybody else, 10 folds of them, calibrating and validating. Looking at the correlation right here is not so bad. The R square is more than 90%, but the only thing is that it for the amount of for the concentration of PM2.5, which is high concentration, which we tend to undershoot those value. And then talking about when the PM2.5 goes low, we tend to overshoot a little bit. We are trying to make it even better for now. And then after we got those results, we put it in a very friendly interface. We called this application the air quality tracker. Is the collaboration between Serbia, Southeast Asia, Thailand, Pollution Control Department, and GISDA. Please, if you have time, you can try it out. This is we have been through a soft launch already. So please give the feedback right here. What it does in this tool, of course, it gives you a 3-day forecast of the PM2.5 at a every 3-hour interval. Right now, we provide the PM2.5 from the GEOS5 model, and also, there is a first satellite that is a geostationary satellite. Is the GEMS data from Korea. So we are working with the Korea team, and now we have put the nitrogen dioxide from GEMS sensor into our tool as well. Also, we display the fire hotspots from the firm system. We are also developing a mobile application version too. And then back to what Dr. Sakda has presented. This kind of thing, okay, let's think about this. We have an ability to use WolfChem or the satellite model, as I just presented. The farmer, okay, as Dr. Sakda presented, pinpoint the location from his phone. Everybody has the GPS. He books the day and time he wants to conduct the burning activity. Then the application, burn check application, sends those location to request for the forecast data from Wolfram or satellite model, what will be the condition of him to qualify on that specific date and location? If it goes too much, if it's gonna be so high, so that activities will be not approved, right? So what's next? The application will give an alternative approaches. Okay, please do not burn, but can you do something else? Can you make your residues? Can you make them the biofertilizer, or can you give them to the even sell? Even sell them to the biomass plant to make it to make the electricity, or even So, or even you can talk about the carbon credit. We can change from burning to buying. So will be a win-win situation. So here we are working together, the Serbia Southeast Asia, along with the Thailand Pollution Control Department. We are expertise in the satellite data and models. Thai Pollution Control Department is monitoring the air pollution using the ground instruments. We are joining hand, helping Laos PDR, the Ministry of Natural Resources and Environment, where Bulani is the focal point, to enhance the capacity of the officers in Laos, and then to show the collaboration between Thailand and Laos, which will address the transboundary haze management. And then back to one question in the previous section about the awareness raising event, right? Besides the capacity development activities that we are working on right now, towards the end of the year, this is the 3 years project. So towards the end of every year until 2026, we will have an awareness raising. We will go with, we have some options we just discussed. One option is to have an exhibition in the public place. The other one is to organize the hackathon for the youth and the university students. And the other one is to work with there is a volunteer group in Laos. They call it the Science and Environment Seed. They are working to promote the environmental friendly way into changing from burning to to alternative approaches in the village level. We can go with them, and that's one thing. So I would like to end up my presentation right here. Thank you very much.
Thank you so much, AJ. Please, to the audience, if you have any questions, write them down in the chat and we'll go back to them after the last presentation. So now we'll move to the final presentation of the day by Mr. Ekachai Lojanafiwat, who is project manager at GIZ Thailand and a research associate at the Asian Institute of Technology. It will tell us more about how GIZ is working on integrated approaches for air quality management and climate change in Southeast Asia. Ekachai, the floor is yours.
Okay, thank you so much to provide us the opportunity to share our project today. So for the GIZ in the Southeast Asia, that we have a many kind of project in this region. So today I would like to mention about the air pollution project in the region, which is we have an ongoing project and also upcoming project, which is gonna start the beginning of next year. And I would like to introduce the overall picture of our project in the region first. And first of all, that our project is implemented in many areas in the region. For example, like climate policy, agriculture, or green industry, energy, transport, and natural resources and biodiversity, which is this air pollution project is under this cluster. And I would like to start with the first project, that the ongoing project, which is run from August 2022 until the end of this year. This project is kind of the preparation phase for the bigger project. I would like to tell the story that for the GIZ, we work on the air pollution area since the last project is 2015, and after that we focus in another area like climate change, not air pollution directly. And the ministry in Germany saw that the data like from the PCD or ADPC that show that okay, during these 2-3 years, so we have haze pollution really high during the beginning of the year. So let's see that are there any opportunity to develop the activity or project in the region. And then from this 2.5-year project, so we try to focus on the 3 areas. The first one is policy, the second one is capacity building, and the last one is the awareness raising. And we realize that there are many donor agency work on this topic already, but we try to find the gap that we can work in that area. And this year we got the one final report that we try to gather information on the ground and also from the policy level that where should we do and what should we do also in the region. And we found that there are 2 characters of the air pollution in the region. I mean, for the haze pollution, is the southern part of the ASEAN and the northern part of the ASEAN. So as the PCD and ADPC mentioned before, that during the beginning of the year, so it's kind of like a seasonal air pollution. So that's why we would like to focus on the northern part of the ASEAN for the upcoming project that's gonna begin next year. So we will focus in Thailand, Cambodia, Laos, and also have a small activity in Vietnam. And in detail for this, this project is a 3 years project. We will start next year, 2025, and 2028 with 4 million euros. And we implement in 4 countries. And also have the package for the regional package also. So our approach, I would like to identify like this. So we have 3 levels. The first level is a regional level, which is we will do the policy support to the ASEAN-wide SLCP cooperation. And the second level is the GMS, so Greater Mekong Sub-region. So we will focus on these 4 countries. And the last one is a country level. So we will go on the ground. So which in each country, what kind of the activity or support that they need. So we will support in that activity. And the one in the box that the promotion of the SLCP mitigation at the Greater Mekong Sub-region level. So this one we will support for the Regional Committee on Air Quality Management and the guideline for the cross-sector cooperation on the short-lived climate pollutant mitigation also. And another one is a concept for the cross-country data management. I will go in detail later. Okay. We will brief on the first one first as a regional level. So as a regional level, we will do the policy support to ASEAN-wide SLCP cooperation. So this is as we know that there are haze agreement, ASEAN haze agreement for 20 years already, and we also have a haze-free roadmap. This roadmap is a second roadmap already, the revision one. So we would like to continue support the implementation to the ASEAN haze-free roadmap, which is going to implement 2023 until 2030, and support to approach for revising the haze-free agreement with a view to strengthen national implementation. And another thing that we would like to support of a task force process on SLCP mitigation with a cross-sector approach and with the involvement of stakeholders from different ASEAN working group. And the second output that we will narrow down to the Greater Mekong sub-region. So we would like to promote the SLCP mitigation. As we know that there is a clear sky strategy which is initiated by Thailand and has the member as a Thailand, Laos, and Myanmar. So this clear sky strategy is kind of like an ad hoc approach to the haze pollution during the haze season. So this is kind of really the agile body, so it's easy to move and make a decision. So we would like to support this clear sky strategy also. And another thing that we would like to establish knowledge hub on SLCP mitigation, including the science input knowledge exchange for the pilot demonstration and training. And the two things that in the box that I would like to highlight is the first one is support the GMS cooperation process on the short-lived climate pollutant mitigation. And another one that developed the concept on the Mekong data center for advanced data management and use the modeling, data sharing, data use for decision making, including the strategy for sustainable operation of the Mekong data center. Now, in the region, we have the ASEAN data center. Yes, we have, but especially for the Mekong itself, so we would like to support the Mekong region to have this kind of data center also. And the third level is a country level. So before we got this, the objective, the output, and also activity that I show you today. So we go on the ground and then discuss with the potential stakeholder and potential political, the local government, and in Laos, in Thailand, and so in Cambodia. And in Thailand, Thailand would like to focus on two areas, which is the agriculture and also the forest fire. And Laos also same as Thailand and Cambodia, a little bit different. They would like to focus on the agriculture and waste sector. So this is the area that we will support them during the next 3 years in the future. So I would like to share you these two topic and these two projects. So if you would like to get more information about the project and what we plan in the near future, you can scan this QR code or can send us an email, these 3 emails on the screen. And I also send information of this presentation in the chat already. So in case of you have any further question, you can contact me directly. So thank you so much.
Thank you very much, Ekachai. Again, to the audience, please write your questions in the chat. First, we'll start with a question for you, Ekachai. Can you tell us a bit more about the alternatives to crop burning or forest burning that you're trying to support through the project?
For the crop burning, so I think somebody mentioned in the chat already. So we, as a GSZ in the region, for example, in Thailand, so we have the many kind of project that already implement. So we have the agriculture project also, which is in the rice, low methane rice farming. So which is a really good practice in the middle of Thailand. And rice store project, which is apply the circular economy principle, which is implemented in the north of the Thailand. So we have this kind of project on the ground already. and also the connection by the project already. So, but these two projects that I mentioned, they don't determine or analyze in the term of the air pollution angle yet. So we would like to kind of like add on this angle for these 2 or 3 projects. So it's kind of like we will plug in our activity into the activity that on the ground already. So this is kind of like to reduce the crop burning. We will not deal with the farmer directly, but we try to find the measure that how to make the activity, the farmer practice that makes more sustained. Yeah, in the near future. Yes, thank you.
Okay, thank you. Another question, do you see any applications of satellite data to support the implementation of your project?
Yes, actually, we also discussed with Dr. Sakda and AJ also about how can we develop more accurate platform, or even because we would like to focus on the SLCP actually. But now we realize that most of the platform or application it show mostly PM 2.5 hotspot. And we would like to focus more in the black carbon and methane. So we will keep discuss with the political partner and also with the other donor like ADPC. And if anyone in this webinar so would like to share or collaborate with us, so we also open to work with everyone.
Thank you, Akachai. I think now we have a question for AJ. I think you've answered briefly in the chat, AJ, but maybe it would be good for the other audience members if you could repeat yourself. Sorry. The question is about carbon markets, carbon credit markets for farming. Are any of them operational at the moment in the region? And do you know which countries have carbon credit projects and if they are successful? Thank you.
Okay, sure. I have a knowledge only in Thailand for now. Of course, in Thailand we have started the carbon credit market already. I posted the link in the chat box, I believe, and then especially for a agricultural area, there is one organization they developed an application called, if I am correct, please help, FIRE-D, right? FIRE-D, okay, where if the farmers do not buy their residues, they will get the credit, and that will turn into money eventually. Yeah, I can give you the link to this application. Yeah.
Yes, please do. Thank you. Another question for you, AJ. Are there any other applications of satellite monitoring to other pollutants or maybe to other impacts than those that you've already mentioned?
The other satellite application, of course, but they are in the national level. For example, the check fund that's the Thai name is the air pollution monitoring or checking, okay, developed by GISDA in Thailand. They have fused the number of satellites and the model, and then they develop their regression equation analysis to predict the PM 2.5. That's one application. Also, in the regional outlook, there is one organization that ASEAN Specialized Meteorological Center. They have it's not the application, it's the web tool where they used the Wolfram model, the regional scale, and then of course the OS5 model, and they put those forecasts into the website. That is the other thing. But this is important because they are the technical arm of the ASEAN communities. I mean, the Southeast Asia countries community. So each country where they do not have this kind of technology, they can come to the ASMC website to get the data. Yeah, this is important thing, and we are trying to work with them because we don't want to reinvent the wheel, develop the same thing. Yeah.
Of course. Thank you, AJ. And I think we have one final question for you, Ekachai. For the ongoing project, what challenges did you encounter in the process of integrating approaches in the region, considering the various countries and differences in legal frameworks and local context, and how did you address those challenges?
Thank you for the question, and actually there are many challenges I would say. And okay, I would like to mention about this, like okay, maybe in terms of the political level and local level. So the political level to deal with this air pollution in the region actually is not easy. I think for the pollution control department itself, so it's not easy for them also. Why? Because of the actually for the mandate of the pollution control department is law and regulation and standard. And for the mandate to to enforce this law and regulation is not the pollution control department, it's another ministry. And how to solve this problem and how to collaborate between these many department or ministry is not really easy actually. Yeah, I know that this kind of like not common practice, but it's happened almost every country. But we try because we try to be like the bridge between the each ministry and also between the researcher or expert. As AJ mentioned that there are many measures already on the paper, even on the shelf, but why we don't bring it and implement it now? So we still have the higher level of the air pollution. So one thing is I think it's the key thing for now is for about the financial support for the political level or even the local level. So they need some support for the financial also to implement this one. And in the local context, some area they still have the belief that they need to burn to get some kind of like for example some mushroom. So it's kind of like need the heat from the fire, and then it can grow after heating, something like this. And if they don't burn, they could not get this kind of the mushroom. And this mushroom is really the high value in the market. So it's a seasonal mushroom. This is just a small example that there are many the challenges on the ground. So if you would like more information, so yeah, we can have a discussion later also. Yeah, thank you.
Thank you very much, Ekachai. Thank you, AJ. I don't think we have any more questions for now. So I would like to again warmly thank our speakers for their excellent presentations today. Many thanks also to all the participants for your questions. And last information I wanted to share is to let you know that this webinar is the first in a series of CCAC webinars on agricultural burning. And we'll be soon organizing another one to discuss how mechanization in the agricultural sector can support the reduction of burning. So please stay tuned. And again, thank you, everyone.
Thank you, Juliet.